So, Iyarkai today with nature's blessings, we always start all of our sessions. So, thank you so much for joining us today, Balaji sir, and welcome to the MSME Problem Statement Session. Myself, Desika Prabhakar, founder and director of the Purpose Foundation, and we have Lakshmi, COO of the Purpose Foundation. So, this whole initiative about the MSME Problem Statement Session, this is a joint initiative by the United Nations specific wing called Unleashed, as well as our NGO, the Purpose Foundation, where we are trying to reach 100 MSMEs all across India in 16 different themes and collect their real-time problems so that we can do some real-time impact. So how we're going to do this is, as part of the second edition of Hack4Purpose, we're going to gather the problem statements and post it in our website. So our ecosystem of student innovators, mentors, trainers, judges, all of them together will work on innovative technology solutions that can actually help to boost revenues of the MSME. This is how the whole initiative has shaped up. So let me give you some guidelines of the whole initiative. So from June to December, this whole event is going to be conducted. June, the applications will be open, and then by December, we'll be allocating the grants to go forward with building prototypes for all the problem statements. To clarify, there are no costs or charges or payment of any sort in this whole process for the MSMEs. It is only that we want to support MSME and we want to get the problem statements from the MSME. As far as any IP is produced during the process, it will be on a case-to-case basis based on everybody's efforts and inputs given. We will deal with it individually, discussing with all the stakeholders so that it is fair to everyone who is involved. Since it's a unique initiative trying to bridge the college students as well as mentors, trainers, and MSMEs, this is not a guaranteed 100% solution exactly as per your requirement, but maximum we're going to try and give all efforts to give you the solution as to your problems that has been stated. So with that, I think we will go into the main session. So we would request you to introduce yourself, your role in the company, the name of the company, and what are the products and services the company has been doing. So over to you, sir.
Thank you for this opportunity. Nice connecting with you, Desika, and yourself, Lakshmi. So it's pleasure meeting you today to discuss about company and its problem it's facing. So basically, I am Balaji Ilangovan, Vice President Technical of Seagrass Tech Private Limited, which is basically a manufacturer of marine microalgae, focusing on marine strain called Dunlilla salina. So which is rich in beta carotene. So basically our product is a dry biomass of Dunlilla salina rich in carotenoid. So as you all know, carotene is a precursor of vitamin A, and usually it is extracted from different sources. For example, carotenoid is taken from carrot. As you might have heard that eating carrot is good for your good eye health. So similarly, so this Dunlilla salina is a marine microalgae which has the potential to produce this beta carotene. So we don't have to compete with the food product. We don't want to use carrot for extraction of carotene. Rather, we can use algal-based beta carotene for the development of any kind of nutraceutical and pharmaceutical component. As you know, this beta carotene has been given as supplement in a number of cases as a multivitamin. Even the patients going chemotherapy, they are given with supplements of beta carotene added multivitamins in order to give them the boost of their immunity. So that is what we are doing. So basically we are an export oriented unit. So we manufacture marine microalgae in open ratio pond system and dry it and sell the powder to as a raw material to our clients. So basically they are nutraceutical and pharmaceutical companies who developed a product based on our biomass which we are supplying to them. So that is what we are doing. So we have been in existence for around 8 years. So we have an IP so for our process. So we are the only company in India currently doing mass production of this Dunlilla salina. There are very few competitors across the globe who are doing with the same kind of technology.
Thank you so much for a brief introduction. It's a very interesting product that the company is working on, and to stop on the food dependency and to go with my algae. So we would love to see how we can support you on this. Please elaborate to us any of the problem statements that you're facing, particular to your production process or manufacturing, or any of the byproducts that you get during the production. So we can see how these can be provided with innovative solutions. So please elaborate on that.
Yeah, so as I have mentioned, so we use salt water for the production of marine microalgae. So our facility is located very close to the seashore. That is, we are between 300 to 500 meters from the seashore. So we use salt water for the cultivation of this marine microalgae in open raceways pond system. The first challenge what we face is, since we are cultivating in open pond systems, so we are mostly affected due to climatic changes. So the occasional rainfall, monsoon, these are the interrupters in the production, which hinders the production quality and the quantity of production which we are doing. So photobioreactors are seen as a replacement for the production of these marine microalgae. But the challenge is none of the Indian companies are doing any photobioreactor system specifically to utilize salt water for the production of marine microalgae with a affordable cost. So that's a major challenge we have. So in case if there is a solution, if there is a closed reactor system which can be of affordable cost, that can be deployed in seashore related areas, so that would help us to increase quantity of production as well as quality of production, and we can do the production throughout the year without the hindrance on monsoons, and we have some high tide, low tide zones, so we have that disruption as well. So that is one of the problem we are looking some solutions into. That is any closed system or any low cost PBRs which can be deployed in the coastal regions for the cultivation of marine microalgae would provide us a better quality product and better quantity of product for our company. And this is one problem we are facing in the upstream scale. Whereas in terms of downstream, so we are currently extracting the product, that is harvesting the product by using chemical methods. So we use flocculation for harvesting the product out of it. So the challenge remains the same in that as well. So if there is any physical, affordable, low cost filtration method which can be utilized for removing this algae and harvesting this algae would benefit us more for us to increasing the yield of product out of the manufacturing which we are doing, and to reduce the dependency of chemicals for harvesting the product. So any solution to these two problems which I have mentioned will benefit us in a higher way in terms of cost, quantity, quality, and export related revenue for us.
So if we'll just again reiterate it, so we understood it really clearly. I think the first one is the use of, since you are using salt water, you're very close to the seashores for the cultivation, and there are a lot of climatic changes, mainly from the monsoons and from the tides. So you are looking for a low cost alternative of PBRs, that is the photobioreactors, or any closed system where you can cultivate the algae. And the second one on the downstream is there is use of flocculants or chemicals for extracting the beta carotenoid powders that you are producing. So you are looking for a chemical free method which is also affordable and can give you the high yield and purity that you are looking for. Have we got it right so far, sir?
Absolutely. So even carbon sequestration is possible. Currently, there are different companies so deployed. So what they do is they reintroduce mangroves on the coastal regions. So and they raise carbon credits. So there are companies that are doing across the globe. So in terms where we can utilize microalgae as a potential candidate across the coastal region, either in raceway pond or in PBRs. So that will be an major game changer for carbon sequestration and for generating carbon credits as well.
That is a very interesting point on carbon sequestration and carbon credits, as you mentioned. Definitely, algae is one of the major candidates. Like mangroves, algae also has a huge part to play, and that's a very interesting perspective. So, also on, let's talk about the issues that is faced in the cultivation. I'm presuming a lot of contamination also might be something that affects the process in the production or in the open ground. So how are these being addressed? Are any measures that we can do in the technology sense to address the contamination issues?
Yes, as I have mentioned, it's an open system. So open system are prone to contamination, as I have seen. But when it becomes a closed system, the contamination gets controlled. So in open system, when there is a contamination and we use certain kind of permitted chemicals, so to control the contaminants. So that we have to do, or else with the change in the pH in the raceway ponds, which automatically controls the contamination.
So apart from the cost, is there any other disadvantage as such with the photobioreactors as to why people are not integrating it into India? Maybe like is cost the only hindrance, or is there any other reason?
No, cost is a major hindrance. So and we don't have any manufacturer in India who is focusing on PBRs. So most PBRs, when you see any European countries, so there are companies which I know they deployed PBRs for the production of chlorella and other algae. So since they have the manufacturer there, and it does not involve much of a cost for them to do. So it increases the yield. But in terms of India, so that if we want to take any good type of photobioreactors, it has to be imported from any developed countries like US or somewhere in Germany also. So same with respect to the downstream process, the equipments I was talking. So there are some Germany and Poland made instruments, but when you think of importing it, the cost becomes multifold. So it is not affordable. So when we for example, if I say it takes 3 to 5 rupees for me in chemical flocculation, so that may not be the case for me when I import such products and pay the import duty to the government and get it installed. So that's a very big challenge for us. So if there is any low cost manufacturers who can fabricate things in India or anywhere across the globe, so if the cost can be reduced when the maintenance, replacement of the whatever filters, whatever we are talking, if they could be made affordable, any filtration system, any type of filters, natural filters using any natural components, or else an artificially fabricated filter. So that would be also in benefit to it. Not looking for a whole unit, maybe a specific kind of filters can also potentially increase the quantity of product produced in India. The land space that has been utilized will be reduced drastically. For example, if I need a 1 acre of land for setting up an raceway pond, for the same space, for the same quantity of production, it will take around 1/10 of the space. I can set up PBRs and increase the production. So this will become an easier option for us. So when we are deploying it, some affordable new technology based reactors, so or any vertical stacking process. So we have horizontal raceway ponds. If there can be any vertical tower based system, any towers, so not specific to the reactors, any tower type system where it can be vertically stacked, so the volume can be increased for the production, that will benefit not only microalgae system, even in aquaculture based system it will benefit.
That is very interesting. The vertical systems also might be a very good option that we can explore definitely. So towards the end, what I would like to request is, you mentioned about the imports being very, very expensive, right? So what we would request is you can also take time for this, for an estimate of what range of pricing would be very ideal for a photobioreactor, or what kind of capacities is more ideal for the entire industry as such, which will help us to kind of configure the whole technology around that. So typically, if maybe 100 liter per hour, I don't know, I'm just making it up, 100 liter per hour system is the ideal one for everyday production, and you have certain parameters like it should be light sensitive, or it should be you having these features, right? Particular features which you want. It should have a continuous monitoring system, it should see the oxygen level, all of the general parameters which are like mandatory, at least. Not let's say let's forget about the very advanced ones. Let us stick to the very basic critical parameters. And the price range, okay, I need it within 20-30 lakhs or 50 lakhs. I'm just assuming. So if this is a scope that you can give us, it will be very helpful to narrow down our focus to building something towards that. So that is one main thing. The other thing is, now we spoke about upstream a lot. On talking about the downstream purity part, right? Like when you said about the chemical usage. So let us assume going to a mechanical system, there are, I think, centrifuge or other different steps of filtration that happens. And again, there are also machines which come into place which are pretty expensive. There is another, so we need to look at crude methods. So again, for these also, the specifications or the capacities which are feasible for the whole of industry. It can be a range, it does not have to be very specific. So these will help us. So coming towards the end of the product production, so let us assume everything is produced and packed, right? So some of these are very photosensitive, if I'm not wrong, right? Like when you have to export it, again, there are going to be some oxidation or color changes or any other potential problems that you might face in the packaging aspect, or in the shelf life of it, for that sort, or the effects of other stimulants. So what are some problems that maybe we can solve over here, if there are any?
Yes, in terms of packaging, as you have mentioned, so the product is light sensitive and it should not be exposed to air. So basically we vacuum seal the product and send it. But the main issue is we use a lot of plastics material for packing. So it will be of double layer, triple layer, use of plastic based bags. In case if there is any opportunity, so any alternative natural based bags which can hold vacuum. So that would be ideal.
Yes. So as far as the production cost is concerned, which consumes the majority of your production cost? Is it the of course the manufacturing will be maybe the upstream will be like say 50%, or downstream, like can you give us a rough breakup of which is consuming the most cost for you, so that we can understand where we can maybe try to reduce that also?
It's mostly downstream. Downstream
processes are the cost, higher cost.
Yes, because we lose a lot of products. There's a loss of product. So whatever is in the upstream should be whatever measurement, the amount of biomass that should reflect in the downstream. But when we take multiple unit operation, there will be loss in each and every part. So the resulting biomass, the quantity what we expect may not be come to the result. So there may be a 5 to 10% loss in every unit operation. So if we could reduce the number of unit operation, set up a single unit operation, which can provide us better yield, that would be fine. Because since we are using marine water, salt water, so it does not cost us for the upstream. Just a maintenance and understanding the parameters and taking control of the production. So that is the cost deployed in terms of upstream. Whereas in terms of algal production, downstream is expensive one. When we talk about any spirulina plant, so you might have met people. So when you grow spirulina, and if you deploy conventional methods like manual methods for filtering and drying in sun-dried powder, the cost would be very low. So you can get spirulina product for 400 to 500 per kg because downstream is very cheaper. You're not keeping any kind of instrument. It's manual. It can be done easily. So farmers are doing it. But the quality is not protected, and since the quality is not assured, the cost doesn't go higher. So when you talk certain industry who has deployed high cost downstream processing equipments, so when they do it and harvest it, the cost becomes 1,500 to 2,500 per kg. Because of the instruments they are using, because they are retaining the quality of the product. So the downstream consumes most of the cost with respect to algal-based manufacturing.
So the downstream typically, what are the major actions that take place in the downstream so that we can try to simplify it? Like say filtration is unavoidable for sure. So like that, there are the processes which are there which are mandatory, right? So how can we club it to in maybe one machine itself? We can try to see that. Maybe it can be a multi-step, but it can be one machine with the centrifuge and with the filtration, so that finally you get the dried powder in the same machine itself, which is sort of an innovation which we can think of. So what are the major steps that goes in the downstream, and what kind of percentage of purity are you expecting, and what is the level of wastage which is okay, which is acceptable, like overall? If you can say that, that will be great.
So there will be 2 to 3 unit operation that is deployed in the downstream. So whereas when you are harvesting, if ever you are deploying any ultrafiltration unit, so it reduces the water content to 100, it reduces to 30. So what output we get, 30 to 40% of the biomass we get. So after that, when it's taken to centrifuge, and it reduces around the same 1/10. So it becomes a paste kind of product after that. And then it will be loaded in any kind of dryers. It can be freeze dryer, spray dryer, or dryer, whatever, depending upon the process. So there are 3 steps. So if the 2 steps, that is ultrafiltration and centrifugation, can be clubbed, or any effective membrane, though it takes some amount of time, it can be taken as a one process. So that after filtration, we should get as a paste. That is as a thick paste format. If the 2 unit operation can be combined or reduced to 1 unit operation, then the cost will be cut off, time will be cut off, and the amount of yield will also be better.
So definitely downstream, I think that would be a great innovation working towards reducing the number of steps. Also the percentage of wastage typically now what you're facing and what is expected, if you can tell us, that's also great. Like now what kind of wastage are you facing currently in production?
So actually in terms of algae, the yield, whatever is present, so the product, it gets around 1/10 to 1/15. For example, if there is 10 kg of wet biomass that can be harvested, so once it is dried and it comes as a product, it will be around 1 to 1.5 kg after the process. So if the efficiency can be improved to 20 or 25%, if there is no loss in multiple unit operation, when that can be done, when a single system is employed, so we could able to increase productivity with yield of increased yield of 20 to 25%. That would be ideal. Any 5 to 10% increase in the yield would be greatly beneficial for the industry, for any kind of industry, algal-based industry.
Algal-based. Excellent, sir. Okay. I think we have got a lot of great insights to work on.
So thank you for the opportunity, and nice connecting with you, Desika, and yourself, Miss Lakshmi. So thank you for connecting today. It's a pleasure meeting you.
Thank you so much. It was grateful having you, and being from a biotech background, it's always great to connect with someone working in the real-time in the algae industry, as well as doing a lot of innovative products in this sector. So it was very happy and grateful to talk to you. We will definitely keep you updated on the progress and how this goes. Thank you so much for your valuable time, and have a great day, sir. Thank you so much.